Okay, so I'm very happy to have here Professor Michael Ghil from Ecole Normale Supérieure and University of California, Los Angeles for this dynamical system seminar. This is a little bit an exceptional seminar, and actually I would like to ask Professor Roberto Buizza from the Scuola Superiore Sant'Anna to introduce the speaker and to explain a little bit why dynamical systems have to do with climate change.
Thank you very much, Stefano. So it's a pleasure to have Michael Ghil here. So maybe not all of you know, but the Scuole Superiori Federate, Scuola Superiore Normale, Scuola Normale Superiore, Scuola Superiore Sant'Anna, and Istituto Superiore Studi Universitari di Pavia have decided to start working more on climate. They want to give their contribution to try to understand the problem of climate change, understand the impacts of climate change, and so start a new research program, okay? So this is part of an initiative that we are trying to promote. We are meeting and we are designing a series of activities, and this seminar is part of that. So Michael Ghil is a Master of Science in Mechanical Engineering from Technion, PhD in Math from the Courant Institute of Mathematical Sciences of New York. He's very well known in the field of dynamical systems, of atmospheric and ocean dynamics, predictability, data simulation. I met him in workshop where we discussed error growth in the atmosphere, how best to simulate processes using stochastic models, understanding how best to do data simulation. He's now a distinguished professor of Ecole Normale Supérieure at Paris. He worked on many different aspects. I mentioned atmospheric and ocean sciences, dynamical complex systems, extremes, and the theory of extremes, how best to assess extremes, numerical and statistical methods. Today he's going to talk about the linking macroeconomics model and the climate. So I welcome Michael Ghil here in Pisa at Scuola Superiore Normale. Thank you for coming, and the floor is yours.
Thank you very much for the hospitality. I look forward to get to know the Scuole Superiore Federate, or whatever. I gave once a talk in the other room, and it's all very grand and beautiful. And I think it's a great idea to have these distinguished institutions try to provide some further theoretical insights into these important matters. So, okay, this is a new one on me. Okay, I don't think I know how to use this because it's taking too long to point.
I think you have to, sorry.
Okay.
I think you have to use maybe this.
No, this is forward and backward. Anyhow, so just wanted to say that my two institutions here are both in lovely places, each in their own way, but it's a long commute. And I added, of course, Ennio Di Giorgi because I thought that the talk would be over there, but never mind. And I hold special seminar because Stefano Galatolo told me this is not the dynamical system seminar, but anyhow, whatever. So as usual, it's with quite a few people from various places. And actually, the last one alphabetically, Gianna Vivaldo, is here. And if any of what I'm telling you is of interest, there are these additional places where you can find out more. So the first one, which is probably the best organized one, is the website of my research group at UCLA, and then, of course, there's a ResearchGate where there are many things in arbitrary order. So I picked this topic because I understood that Scuola Sant'Anna was going to play a role in this, and I thought of the Scuola Sant'Anna mainly as something that does economics. I was set straight on that. But in any case, one of the times I was here in Pisa, it was in connection with something that they organized at the Palazzo dei Congressi that had to do with econometrics and so on. Okay, so, I'm going to get to endogenous business cycles and fluctuation dissipation pretty soon. Okay, so as you probably know, and I'll remind you, a lot of the challenges posed by climate change have to do with socioeconomic impacts. And basically, again, I'll come back to this, the two things, the climate, the physical part of the climate system and the socioeconomic part have been handled pretty by different groups of people that have a little bit of trouble communicating. I remember that once being at the Isaac Newton Institute in Cambridge, I picked up a very good biography of Wittgenstein that did credit to both his work and his life, and you know, he pointed out the difficulties in communicating, and you encounter those in spades in communicating between economists and social scientists and physical scientists who deal with climate. So this is part of an illustration that it can be done. I was motivated in part to get into this business by having to do shortly before when I moved from being full-time at UCLA to being most of the time at the Ecole Normale in Paris, had to coordinate an EU project on extreme events that tried to deal with both geosciences and the socioeconomic sciences. So we developed some novel tools for both data analysis and modeling. A toolkit that is available that's freeware at UCLA on that website, and key tools for nonlinear and random dynamics and combined modeling and data studies. So motivation for dealing with, again, with extreme events, as we heard before, is a major cost in lives and goods of floods and other extremes. You have to, yeah, no, this doesn't work. And the cost of reconstruction and infrastructure renewal. So major natural disasters, as major human-made disasters like wars, have two impacts. One is the immediate cost to lives and infrastructure, etc. The other one is the cost of reconstruction and infrastructure renewal. This happens to be a huge flood in Peru, which had occurred just before I gave this talk to another audience, but it can serve anything else. So I'm going to get back to this cost in the process of the talk. So the second motivation is precisely this difficulty in communicating. So I'm sure that you've all heard about the the intergovernmental program on climate change. Again, I emphasize most people think that it is international, and I spoke myself. It's intergovernmental. It's something mandated by the United States and a certain convention, etc. And it produces assessment reports every few years. We're now into the 6th one. And it is still the case that there are 3 separate working groups, each one with its various sources of uncertainties. So the physical, these are the covers of the 3 reports, I think, from the 4th one. So there's a physical science basis, and then there's impact, adaptation, and vulnerability, and then there's mitigation. Okay? So again, there's a question of physical and socioeconomic modeling, separate versus coupling, and I won't have the time to discuss ethics and policy issues, which are very challenging also and quite interesting. So for those, since I understand that there are some economists, at least it's a non-empty set, Okay, I know that, okay. But most of the people here are not economists. You know, first of all, you have to understand that not only don't have economists trouble communicating with physical scientists, but they also have trouble communicating amongst themselves. There are institutions, including in this country, that have 3 separate departments: macroeconomics, microeconomics, and econometrics. Okay? I see some people nodding, so there must be another economist aside from the one that I met at lunch, you know. So, okay? So what is macroeconomics? Well, as I said, there are these subdisciplines: national or regional economy as a whole, individual, household, and firms, methodology of both macro and microeconomics. So macroeconomic variables and indicators is one about which everybody has heard. Gross domestic product, GDP. When I give the talk in France, I remind them this is Produit Intérieur Brut, PIB. Production, demand, capital, profits, gross, net, price level, wages, unemployment rate, etc., etc. So some of these are in physical units, others are monetary, some are observable as time series, and some are not. So the outline now is I'm going to talk about something which, economics is still a little bit like religion. There are orthodox and heterodox economists. You know, the orthodox are those who believe that there's equilibrium, albeit generalized equilibrium, and the heterodox ones think that the economy does something by itself, not just, you know, in equilibrium subject to outside inputs. We're going to talk about this is bad. This is, you know, you get burnt at the stake by, okay? Endogenous business cycles, so you have sawtooth-shaped business cycles with a 5 to 6 year period. And then we look at the impact of natural hazards, not on an economy in equilibrium, but on an economy that does stuff. So incidentally, what's called endogenous in economics is what we call intrinsic or natural variability in climate. And now we're coming to the really interesting part. In doing this modeling, we found a vulnerability paradox, which led me to formulate this fluctuation dissipation, this hypothesis of fluctuation dissipation being present in the economy as well as in the physical processes. And then we went, of course, to check with the best macroeconomic indicators we could find, US macroeconomic indicators, with this methodology that I'm going to outline to you, and then using the Bureau of Economic Analysis data to confirm the vulnerability paradox. And then we looked further to EU and world data, and I'll tell you a little bit about that and conclude with some remarks on bibliography. Okay, so endogenous business cycles. A tale of two theories. I mean, you know Dickens's book, A Tale of Two Cities, French Revolution on either side of the channel. So in what's called real cycle theory, here the real, it does not mean that they are real. It means that it doesn't take into account monetary things. Okay? Business cycles and economic fluctuations arise from exogenous, real, i.e. not monetary shocks, like changes in productivity or in energy prices, or from fiscal shocks. Aside from these exogenous shocks, the economic system is stable, all markets are at equilibrium, and there is no involuntary unemployment. Okay? Deviations from equilibrium are damped more or less rapidly, acting on the economy, therefore, e.g. recovery policies is not useful. Now you can tell who believes in this, okay? Okay? So in endogenous business cycle, EBC or EnBC models, cyclical behavior originates from endogenous instabilities in the economic system. So several instabilities have been proposed, so this is not entirely new. This goes back at least to the 20s and 30s, okay? But it's become very unpopular in a couple decades after World War II, and you know, there's a tendency for it to come back, as many other things. So several instabilities have been proposed. Profitability, investment instability, delays in investment, income distribution. Acting on the economy can therefore have positive effects by stabilizing it or by shifting its mean state. Okay, so again, you can tell who believes in this. Okay? So the blessings of interdisciplinarity, I mean, since I have some friends in London, I went to Bloomsbury, and here's, John Keynes's home in Bloomsbury, and in front of this home, in the square, there is this photo of him with his lover, Duncan Grant, who was a poet, okay, May 2008, so... so there are many things in which Keynes's name shows up these days, and I don't remember all the prefixes. One of them is post-Keynesian, but there are many other ones, and people not only don't, the heterodox and talk to the orthodox, but also between the heterodox there are various sects, and they distinguish themselves by the prefix attached to the name of Keynes. So this Nedim was essentially part of the PhD thesis at the EHESS, the École des Hautes Études en Sciences Sociales in Paris, of Stéphane Algat and Patrice Dumas, under the main guidance of Jean-Charles Lourcade, but I sort of participated in that guidance, and this is a first paper we published in that. So this Nedim, non-equilibrium, so Stéphane is now a senior climate scientist at the World Bank. He does real stuff, okay? He represents an economy with one producer, one consumer, one goods that is used to both consume and invest. It is based on the Solow model. So Solow got the Nobel Prize for this model, which said, capitalist economies work and socialist ones don't. There's exponential growth, and over there, forget it. So in which all equilibrium he constrains. So, Solow said production equals demand and other such likely equalities. Okay? So here what we did is set all equilibrium constraints are replaced by dynamic relations that involve adjustment delays. So in mathematical terms, these are now differential equations, ODEs. Okay? And I'm not going to write them down, but you can find them in these papers, and I'm going to tell you more about it. So the Nedim equilibrium is neoclassical, okay, and identical to that in the original Solow model. When at equilibrium, it's the same thing. If the parameters are changing slowly, Nedim has the same trajectory as a Solow model. So what we call in physics adiabatic, slow changes, okay? Because of market adjustment delays, Nedim model exhibits Keynesian features with transient trajectory segments in response to shocks. So Nedim possesses endogenous business cycles, and I'm going to show you those. Okay, so this is again to give you an idea some of the macroeconomic indicators for the United States. Here's GDP, so there's the exponential growth that Solow got the Nobel Prize for, and prices are a little bit more complicated. Exports, employment. Now, you'll see that in spite of the fact that you can hardly tell the wiggles have very serious consequences on employment. Okay, the difference between 3.5% unemployment and 12% unemployment is very serious for people who are unemployed. Okay, so there is something to talk about in terms of those wiggles. Okay, so this decomposes now the GDP exponential growth into the long-term growth, the trend, and these are the short-term fluctuations, the residuals after trend removing. Okay, so you see that because the mean grows exponentially, the variance also, increases. So you have to take care of this when you do analysis of these time series. Okay, so without having shown you exactly the equations, well, there are about 7 or 8 ordinary differential equations, and then some algebraic relations between different things, such as the Cobb-Douglas function for productivity. And there is a parameter, which is this investment coefficient, which has to do with how much you reinvest into the economy. And this is one of the things that measures the behavior, and there is a Hopf bifurcation. Actually, there's a very interesting story. When I got to the Ecole Normale, one of my former students, Hervé Le Treut, who is now a member of the French Academy of Sciences and many other things, introduced to me Stefan Algat, who was doing his PhD thesis. Stefan actually came to me and showed me the model and says, I can't find its equilibrium. Okay? So I looked him in the eyes and I said, did you ever see an economy that is in equilibrium? Okay, so then, he was a former student of the Ecole Polytechnique, not quite the Ecole Normale, but not so bad. Okay, so he learned very quickly dynamical systems analysis, and he also tried to teach me a little bit of economics. And so this is a Hopf bifurcation. So we did find the equilibrium by varying parameters. That was the only thing that was the matter. And for different values of this parameter, you see here the purely periodic behavior. So this is GDP, and this is the projection onto the plane of employment rate and wages. So you see a nice ellipse. And then as you increase this parameter, you have transition to chaos, irregular behavior. You can see these kinks forming here in the torus. Okay, going even harder, you see, again, more and more irregular, sawtooth type, relaxation type oscillations. Okay, so now if we take a typical limit cycle, okay, and look at it in time. So first of all, it has a periodicity of roughly 5 to 6 years. And this is just the output, and actually it's normalized in a certain way to the European economy at the time when we did the work. So this is billions of euros, employment rate in percentage points. Okay. And so this endogenous business cycle originates from the profit-investment relationship. I put down there, when the US economy went well for a while and the evil empire collapsed and so on, there was this guy Fukuyama, said end of history. Well, we've seen what happened to that prediction. It might be the end of history, but not quite the way that he meant it, okay? So, the business cycle here is higher profits, more investment, larger demand, higher profits, etc. And the business cycles are limited in amplitude by 3 processes: increase in labor cost when employment is high, constraints in production, the consequent inflation in goods prices when demand increases too rapidly. Financial considerations are not present in our model. These are just in a general way. That's what Hopf bifurcations are about. You have some sort of an instability which is originally linear, but then has to saturate, okay, in physical models because you run out of energy, well, here for other reasons. So EnBC models need to be calibrated and validated. It's harder than for real business cycle models because they're fast and slow processes. In the real ones, they're only slow processes. Need a better definition of the business cycle, so study of these data. So the things that you typically read about in the press is NBR, the National Bureau of Economic Research, which, however, is essentially a not-for-profit. The data come from the BA, which is the government agency, the Bureau of Economic Analysis. Okay? So here we go. Catastrophes on the state of the economy. So when does a disaster cause greater long-term damages to an economy? During an expansion phase or during a recession? Now, if I didn't tell you that it's a paradox, you would answer, during a recession, of course. And as a matter of fact, I'm sorry that I didn't keep. I remember, I subscribed to Time magazine to keep myself in contact with the United States. And there was an article by one of the leading economists, I forget, Nobel laureate or something, who said exactly that. I'm sorry that I didn't keep that to show you. But actually, so now we're going to, this comes in the second paper in ecological economics. And it is actually in this paper that there is an appendix that has all the equations of the model in one place rather than deriving them one by one. Okay, you can read them all on 1 or 2 pages. Okay, so here we go, production in arbitrary units this time, business cycle recession, fast, expansion slow, so that's typical of relaxation oscillations. Okay, now here comes the vulnerability paradox. See, this is on the lower plot is the production losses, okay? So this has to do not with a direct damage, a factory is destroyed, but with the fact that that factory no longer produces. Okay? So they are at a minimum in a recession, and okay. And they are at a maximum if the disaster affects an economy in expansion. Now, after the fact, after seeing the numbers coming out of the computer, you stop and you think, and you realize why that might be. Because when the economy is in expansion, you know, let's say you live in Florida and Hurricane Andrew just blew the roof off your house. When you want to hire somebody, first of all, you don't find them because they're already employed, and then they will charge you a lot more. Okay? So that's a very simple explanation of this paradox in practical terms. However, this also suggests, so the word for vulnerability paradox comes from Stefan, who is very preoccupied by the real impacts on real people. And, but I said, but then shouldn't there be a fluctuation-dissipation relation? In other words, we could check this in data. We don't have enough disasters to check it, fortunately. But we could go to some data without disasters and see whether, you know, what's called in finance volatility, you know, the variance increases during expansions. Okay? So, well, first of all, you're going to tell me, oh, this is very sexy, you have Hopf bifurcations, you have transition to chaos, and so on. But does this make any difference to the net impact over time of disasters? So the answer is yes. Okay, so again, now this is a calibration, no investment flexibility, that parameter alpha inv equals 0, low flexibility equal 1, high 2.5. Economic dynamics, the two first cases are stable equilibrium, so the mean GDP losses, percent of baseline GDP, here are pretty large. Stable equilibrium over here, they're very low, and then they become again larger, okay, as you go into limit cycle regime, okay? So in the long run, this observation does matter, okay? It affects, you know, if you're thinking now not about next month or past months, but about the next 10 or 20 years, this sort of thing does matter. Okay, now, check the hypothesis. So methodology, singular spectrum analysis and the multi-channel version. Well, there is one person in this room who knows this very well because she worked on it. And basically, well, the conclusion is the BA data confirm the vulnerability paradox, but let me show you now how. So basically, singular spectrum analysis is just Cahoon and Loew plus a particular observation that we made with my then postdoc, Robert Votard, in a paper in Physica D, namely that pairs of eigenvalues subject to all sorts of significance tests, which are the meat of that freeware toolkit, these pairs correspond to data adaptive sines and cosines. You know, sines and cosines are shifted by a quarter period, okay? And, well, in a Fourier decomposition, they will have the same eigenvalues, and these are just the nonlinear counterparts of that. Okay, so I'm just going to, well, okay, let me go through this more slowly. So in meteorology first, and then oceanography and climate sciences in general, the eigenfunctions of Cahoon and Loew and eigenvectors in discrete case are called empirical orthogonal functions. Basically, if you take successive maps, so what you see there on the left side, okay, let's say that you have successive maps of something. Phi stands for geopotential, never mind. Think about surface temperatures, which are functions of time and space. So you decompose them in this way, sum over k of AKT, which are the principal components, and the EKs, which are the of X, which are the EOFs. So this is the statistical counterpart of separability for linear PDEs. Okay? And then how do you get? Well, in principle, you get this by taking the expectation operator, but you don't have expectation operators in real life, so you just take averages over that field at point X and Y to form your matrix in the discrete case XY. You diagonalize that matrix, and then that's your decomposition. So X here is space. On the left-hand side is what the right-hand side is what happens in singular spectrum analysis. So you have now empirical orthogonal function in time. So you decompose the time series of t, time t, and lag s in this way. So now here the units were different things. These were seconds or years, and those were meters or degrees or whatever. Here they're sort of the same thing, they're the same units, but basically the empirical function is within the window of your time series analysis, and everything else proceeds the same way, okay? Except that now the lambda k pairs correspond to these pairs of sines and cosines, okay? Nothing terribly dramatic, but it turns out it's useful. So again, this is what people sometimes call the scree diagram. In English, scree is what you have on mountains, you know, and little stones, okay? And so if you order them by the amount of variance, so those eigenvalues are variances, okay? You have typically or often you have a break which says you can't tell much about this tail. You might just as well assume it's statistical, but you are more interested in what happens there and in particular in the pairs. Okay? So I can come back to this during the question period. Okay? So SSA decomposes geophysical ladder time series into temporal EOFs and principal components. So there is, for instance, up there, the time series that has a lot to do with the El Nino Southern Oscillation, sea surface temperature anomaly. So again, in climate, anomaly is not like in medicine. It's not something bad. It's just a difference between instantaneous and long-term mean. So you see this is something about 50 years, and it looks a little bit irregular. But then when you apply to it this decomposition, there's a leading pair, which is a period of 4 years. And you see, indeed, they are in quadrature, in other words, like sines and cosines. And then you can project onto these reconstructed components. So the leading pair looks like this, and if you compare it with the original time series, you see that it does capture a lot of the longer term behavior, and it does so much better than running means or anything else that we know of. Okay? So, okay, so we did this terrible thing to those BA data, okay? So we looked at 9 variables from the Bureau of Economic Analysis: GDP, investment, consumption, employment rate, price, total wage, imports, exports, and change in private inventory. Sorry, this is no longer submitted. This has been published a while ago. I forgot to update this transparency. So basically, you have the raw data here, just detrended and standardized, in other words, unit variance. So there are 9 channels, these 9 indices, and you take a window width of 24 quarters, because in economics you think about quarters, okay, rather than months like you do in climate. And so 24 quarters is 6 years. And you have this adaptive filtering. So basically, this corresponds to a data adaptive form of filtering rather than having all sorts of prescribed filters that all sorts of books in time series analysis are full of. You know, 32 coefficients for the window, etc. And you see that the different colors correspond to the different indices. And the vertical bands are the recessions, the US recessions as defined by the NBR. Now, if you look at what it says on their website, to this day, the NBR doesn't really have a fully objective criteria for defining its recessions, okay? So this is supposed to replace that by being, as objective as possible. You can never be entirely objective because you still have to fix your window width and you have to do certain things, but anyhow. Okay, so, well, again, you just see very clearly that things are going down here. That's pretty obvious. But the way, okay, so the stylized, okay, this is again an economics term, the stylized fact. People have been aware of the fact that ups and downs are not just GDP. There are all these other things, and there is a crying out loud need for these stylized facts which define a business cycle. So what we do here is we define the so-called local variance, which is defined in this way, the sum of the case of the principal components, where K is a set that we're interested in, the subset of these reconstructed components, divided by the entire set. The D is a dimension, the M is a window width. And you look now, so the upper panel is a local variance fraction of PCs 1 and 2, the leading pair. And the lower panel is the rest from 3 to 100, okay? And you compare this with the bands, and you see the earlier part of the record, as usual in economics, like in climate, is not of the same quality. But if you look sort of at the second half of the record, it's quite clear that this is a noise fraction, which is a minimum during recessions. Okay? So that means the volatility is indeed, as postulated from the theoretical model, a minimum during recessions and a maximum during expansions. Okay? Now, I think that most people in this room are familiar with fluctuation dissipation, including nonequilibrium. Okay? So this is clearly nonequilibrium, but numerically you get it. Okay, so now from the United States on to European Union and world data. So I'm sorry, I will not talk a lot about the paper that Gianna Vivaldo was involved in, which dealt with just 3 European countries and their correlations with the USA. I'm just going to tell you very quickly that careful analysis confirmed what you would suspect, that the UK is much more correlated with the United States and the European countries are more correlated amongst themselves. Okay? And so I'm just going to show you the results for the world, for the global analysis. Okay. Okay, so it turns out, the question whether there is a world business cycle has been in the literature for a long time. The references are in the paper. I looked at those papers, while we were writing up the paper, this paper, and there's nothing like this, okay? Some say yes, some say no, some say maybe. This one says, okay, there is synchronization. Again, I haven't gone, synchronization, again, is a big topic in the physical sciences and by now also, of course, in the biological sciences. The word shows up in those papers that we are citing, but it's not done the way the physicists do it, and here we did it the way the physicists do it, okay? So what you're seeing here is, again, for all these different indices, GDP, export, import, consumption, etc., you have the different colors, and this gives you the phase of these indices within this synchronized world business cycle, okay, lagging the United States. Now, this is a very interesting map. This is Andreas Groth, who, really did the work on this paper like and a lot of other papers that we did together. This is modern cartography. In other words, the areas are proportional to the GDP of the country. Okay? And basically, you can see that, what did I tell you? Great Britain is perfectly aligned, well, except for that red thing, which is the exports, with the United States. And most other countries are aligned pretty well as well, except for China, which is in anti-phase. Okay? And Japan is a little bit more, and Russia is also a little bit more spread out, etc. So again, this is of some interest to economists. I don't know whether they're going to buy them because I don't have a named chair at Princeton in economics. So neither does Andreas Groth, and that's the least it takes in order for economists to believe you. Okay. But on the other hand, this is just, again, something out of Time magazine, from the source being, again, the NBER. These are recessions and expansions from the Great Depression to today, with today being, 2008. And if you count the number of recessions and you divide the time span by that number of recessions, you get roughly 5 to 6 years. So this is clearly, the claim is not that there is a really purely periodic cycle, but that there is something irregular which has such a mean period. Okay? So, we're almost there, ready for questions, concluding remarks and bibliography. Okay, a hierarchy of economic models and data analysis methods. So the highly idealized aggregate. So, again, these days, economists, even heterodox economists, no longer like aggregate models. You have to at least to do an agent-based model. Okay, I remember being at some meeting some years ago. If I forget exactly what it's called, World Economic Forum has some GSR. Okay, there was a meeting in Erice, and with a lot of economists, and there was a guy there, Axtel from George Mason University, who said, if Ben Bernanke, instead of playing with his laptop computer, would do what I do, which having every American man, woman, and child in my computer, things would go much better. Well, I think Ben Bernanke didn't do so badly with his laptop. But in any case, aggregate is not terribly popular. Cobb Douglas is out of favor. Anyhow, this highly idealized aggregate model exhibits fairly realistic endogenous business cycles. But real cycle model, you can get a sawtooth, because basically it's linear and driven by white noise. So there's no way that you can get, except if you sort of put these residues that are supposed to, the so-called production, I forget exactly what they're called, they put them in by hand. Okay? It has a sawtooth shape that has about the right period. There's a pretty good, obviously not everything is perfect in it. It displays its vulnerability, paradox, extreme event consequences depend on the state of the economy. Okay, and they are more severe during an expansion than a recession. This paradox is supported by consequences of the Izmit Marmara earthquake 1999. There was a World Bank report. Turkey was in a recession at the time, so everything went swimmingly because all these construction sharks got a lot of business. Okay? So reconstruction progress after 2 hurricane seasons in Florida also seems to support this. So you need a better quantitative characterization of business cycles by such spectral methods and phase synchronization. And you need data assimilation, okay? Because again, as I said, some of these things we do not have records. In spite of the incredible success of Thomas Piketty's book, we don't really have a lot of information for the entire 20th century on all these 9 variables, etc. So US economic data support a nonlinear FDT result a la Ruel. You also do need more detailed regional and sectorial models, so we've done some of that, but I don't have the time to talk about today. If you ever invite me back after this, I'll try to talk to you about Boolean models to study the economy as a network of businesses, suppliers, and producers, etc. compare aggregate models with agent-based models, and of course with the data. And here are some references. So I just highlighted the last two papers, which were published just a year ago, actually in December of 2016. There was a special issue of Chaos on synchronization, and they were part of that issue. And some of the other references that I mentioned to you. So this is the one that had to do, among other things, with the Italian economy. And as I said, this is one that you can find all the equations of the model in one place. Okay? So the deeper motivations of economic modeling, this is out of the New Yorker. Really, Carl, can't I mention the high price of kohlrabi without getting a manifesto? Okay. That's it, folks. Thank you very much. So we have a lot of time for questions, comments. You know, I should say that, Stefano Algatti is certainly a pretty remarkable guy. You know, already as a graduate student, he led one of the work packages of this European project on extreme events. And then he did a postdoc at Stanford. As a matter of fact, nominally it was with Steve Schneider, RIP. You know, it's pretty well known in climate change and its impacts. Passed away, unfortunately, since. He didn't see much of Steve, who was traveling all the time. But he did present a talk on the results of the model to the economics department at Stanford. And basically, there was a guy there, or two, who were expecting a Nobel Prize for, you know, generalized economic theory. And so they basically wouldn't let him talk for about half an hour. And, you know, the usual reaction is, there's a particularly good French phrase, c'est pas comme ça qu'on fait. That's not what you do, okay? So sorry, guys, I mean, that's what we did, and terribly. Okay.
The macro data from the United States with the analysis you make really support the 5-6 years estimate for this?
Yeah. If you look at, sorry. Okay, so we need to go back.
Two components, right?
Huh?
Two.
Yeah. No, well, here the global one is 7 to 11. I mean, it's somewhat longer, but
Somewhat longer. Okay.
Yeah, but the leading, I mean, you know, you see that it's pretty irregular, okay? But there is a pair which has roughly this sort of periodicity. Now, clearly the system is not really stationary, you know. And one of the mysteries about this SSA, which, you know, maybe one day we can talk about, is that in spite of the fact that typically Carhoun and Loev requires at least weak stationarity, okay? This I actually learned because I mentioned to you in your office this former student of mine, the one who did his PhD thesis at Courant on Boolean delay equations, and who went into finance in the 90s when the market was very good, and who had his own fund and who survived the Depression, etc. And so when he first went to, before this became fashionable, he did not in the 90s, already in the late 80s. He went to Morgan Stanley, which had at the time something called the Analytical Trading Division, which was about a dozen people with PhDs in physics and math, which at the time wasn't at all as popular as it is now. The head of the group was a guy who was a real trader who had no PhD. Anyhow, I had another student, a grad student or postdoc at the time, who really became interested in this, and so that's when I discovered that actually SSA does pretty well with long-term trends. So I showed you at the beginning, sorry, I should do this on the computer, but I'm not used to, I don't see well at the magnification. Ah, here, okay? So, sorry. You know, this would say that it shouldn't work, okay? But it does work. We learned that in the 80s, and we didn't publish it at the time, that it does very well. So SSA does very well at extracting what we call a data adaptive trend. Anything that is longer than your window is your data adaptive trend. And once you have extracted that, everything else works beautifully. You know, it doesn't know that it needs weak stationarity. Sorry, okay? But I still would like to understand mathematically why, okay? So, and also the business about these nonlinear sine-cosine pairs is not something that has been rigorously proven or anything like that, okay? So all of this, it's like many other things, it's terribly useful, but not mathematically justified.
I was asking because there is this, in finance, there is this indicator of this sort of bubble indicator of Shiller, which is called the cyclically adjusted price-earning ratio, which actually has very old roots because it's described for the first time in the book of Graham on valuation of stocks in the 30s. And the idea is that you instead of using the price-earning ratio, you use an average of the earnings. First of all, you deflationate the earnings. You look at real earnings, not nominal earnings, and you make the average over 10 years of the earnings, and then you make the ratio. And this it's a little bit controversial from the point of view of econometrics because, of course, the statistical validation of this indicator as a forecaster of long-term returns in the stock market is extremely complicated to do because you are already using 10 years of data to compute this, and you want to forecast returns over 10 years plus in the future. Then, of course, how many points, how many independent windows you have? 10, 5, I mean, it's extremely complicated. But I mean, the idea was exactly to assess the profitability of a firm over a full or maybe even more than one full business cycle. So that's so I was asking, and I wonder whether whether one may try or not, perhaps, to do a similar analysis on the data set of Shiller, and see if actually the 10 years is justified.
If I can get you interested, you know, when I was here the last time in Sala dell'Iste, we talked about SSA and, you know, things that would need to be done mathematically, but or economically. I mean, you know, as I say, these are in many ways results of opportunity. You know, I don't have a position in an economics department. I don't have oodles of economics PhDs, and, you know, so I think that this thing that you have in mind of doing here could be one of the interesting things that mathematicians could contribute to this. Okay, yeah.
I want to move a discussion towards the predictability of phenomena in, if you want, in the atmosphere and in economy. If I think about the word where I come from, atmosphere, no, we have like precipitation, intense precipitation events. The characteristic times of these events is few hours, say 6 hours. We manage to predict them 2 or 3 days in advance. Synoptic scale features, like large scale features, they have a characteristic time of few days, and we can predict them 10, 15 days ahead. Then you go to a longer scale. So essentially, in the atmosphere, we know that there is predictability, or we can also, there is prediction. We can predict events up to 2, 3, maybe if you're lucky, 4 or 5 times their characteristic time. Okay, we can predict them now with the tools that we have, and roughly few times their characteristic times. I wonder where we are in economics, because every time I think about economics predictions of interest rates, of GDP growth, or whatever, it looks to me as if in economics there is much, much less predictability. So the question is, given that you've been working with the dynamical systems applied to the atmosphere and now with economic models, what's your feeling about the predictability of events in the economic world?
Well, first of all, I haven't done real-time forecasting in economics. You know, as I think I mentioned in our discussion this morning, I have done that for ENSO. And there, it is still the situation that, if I can get this back up on the screen, when I was explaining SSA, I showed you here, you know, this indicator. So again, El Nino Southern Oscillation is, first of all, there's a seasonal cycle. That's why it's called El Nino. Okay, but these events are anomalies from the usual seasonal cycle. And so over there you see degrees Celsius, you know, in the, roughly speaking, Eastern Tropical Pacific. And so you see that the leading pair is 4 years. But there's another periodicity, there's a beat between this and the so-called quasi-biennial oscillation. So basically the big models, those that might predict your rainfall event that you mentioned before, don't do any better, you know, this is certified by third parties, than some of these simple tools, okay? So basically, if you have a periodic component, you know, that is still only a fraction of the total variance, you can simply, by the fact of the presence of that, and depending on its percent of variance, predict 1/4 to 1/2 of the period, rather than multiples of the period, okay? So now I don't know where to place these economic things with respect to that. If you talk about the climate of economics, you know, if you think that these endogenous business cycles, or business cycles, whatever they might be their causes, have a periodicity of 5 to 6 years, you might say, I can maybe predict for 2 to 3 years at best. Now, if anybody comes up with an economic model that has the same capabilities as a GCM, you know, in terms of predicting weather, in other words, saying, you know, you are going to have a terrible crisis in Thailand in December of 2021, well, you know, that's certainly going to be a Nobel Prize in economics, okay? But I don't see that in the immediate future. Okay, so I would say that the sort of stuff that I'm showing you here, and again, you know, the tools are very different from the ones which I used in mathematical finance, because this is not split-second, you know, fluctuations of the daily markets. This is, you know, saying whether the world economy is going to be happier in 2 or 3 years from now or not. But I would say that this type of tools, not necessarily exactly what I showed you, but some, you know, it can be empirical model reduction of data, okay? So, you know, you can call it, if you wish, deep learning or artificial intelligence or whatever, but it's really just massaging data, you know, okay? Something like that should be able to help a little bit. But on the other hand, you know, who could have predicted the election of Donald Trump, you know, and trade war with China, which might, you know, do incredible harm to the world economy. So the climate system is complicated. The human system is even more complicated. And again, you know, we've had bifurcations for a long time, going back to Euler and the buckling of a beam. Now we call them tipping points, so everybody got excited and jumping up and down. But, you know, things like the murder of Rabin for the Middle East or the election of Trump for the entire world are really events which are not predictable by any quantitative tool. Yeah.
Actually, I would like to ask a couple of questions. So the first one is a clarifying question. I would like to go back to the slide when you show us the world and the connection, the synchronization, actually.
Oh,
about the macroeconomic time series.
World business cycle.
Yeah,
okay.
Exactly.
So
because this is built based on the definition of synchronization you given before.
Okay, so I don't know
in principle, very good, this one.
Okay.
In principle, you can repeat the same exercise using the more mundane cross-correlation measure. So the first question, how does the picture change?
No, you don't get that, no.
You get a different picture if you
you don't get, you get a confused picture. I mean, you know, you look at all those references which are in our paper where either the word synchronization just got mentioned, so I found them on the web, or Andreas Groth actually did a serious literature search. And you look at those papers and, you know, they have such classical tools. I mean, of course, economists know correlation and so on. They get contradictory results. And this is, you know, again, you need to do all these tests of statistical significance, etc. It doesn't mean, you know, nothing that you do objectively will guarantee. I mean, I always say, well, I actually have in my talks about singular data, singular spectrum analysis and its various other applications, like, for instance, you know, analyzing the Nile River floods for 1,300 years or something. You know, I have what I call the 10 commandments of the time series analyst, or in French I call them garde-fous, you know, again. So it goes something like this. You have one time series, you have to have some statistical significance test. You get a second time series, you apply that, okay? Then if that's okay, then you try to get totally different part, etc., and so on. And then at the bottom of the list, what really is satisfying is if you have a physical or economic or whatever biological explanation of the phenomenon. Okay? So, you know, this is very solid in terms of...
I don't know if I'm allowed to ask another question or not. Maybe.
No, go ahead.
Oh, okay. The second question has to do with the model that you spoke about at the beginning. Okay, if I understood well, I didn't read the paper, but essentially you had an endogenous business cycle model and you added a kind of exogenous shock.
Yes.
Now, through the production, maybe a production shock, I guess. This is the most natural thing to do. So this is the way of modeling natural disaster. Now, the point is, in your analysis, if I got it right, you essentially look at the recovery of the economy, but keeping with, let's say, ceteris paribus, so all other things being equal.
Exactly.
So the point is, okay, let's assume that the functioning of the economic system remains the same, then the system is hit by a shock, and then you see the recovery. But the point is, huge shocks typically also have an impact on the functioning of the economic system, okay? So, so what I have in mind as an empirical observation is that the most extreme shock that hit the economy in the last century is probably a self-inflicted shock, is the Second World War, in terms of men killed, production.
For this model, there's really no difference between a natural hazard and...
Let me finish. What I wanted to say is, this was an enormous shock. Was there any earthquake? Was there any eruptions, volcanic eruption, in terms of men killed, in terms of productive capacity destroyed, also in terms of the change of the production activity, no more focus on the satisfaction of the need, but so reorientation. The point is, how much time did it take to recover the world? If I remember well, 2 years, probably less than 2 years in terms of GDP. And the recovery was also achieved because the economy grew faster after the disaster than before. Okay, so the point is, the disaster also changed the rules of the game. The assumption about the relationship between investment, wages, the production function, everything changes through such a disaster.
No, the point is very well taken. You know, clearly, for instance, there at one point in formulating the model, you know, the right-hand sides of these ODEs, we had a choice between management-driven and stockholder-driven management. I forget exactly what the equation was, and the plan was at that time with Stefan that we would look at in the published paper, we took one of those and we said we will compare them because clearly, again, intuitively, there's something terrible that has happened with the management-driven industry being replaced by stockholder. I mean, lack of long-term planning and so on. So there are things in the model that can change, you know, and the sorts of things that you're talking about are of that nature. And one can explore that, again, with relatively simple models, but somebody has to do it. I mean, you know. Yeah.
I have a question and a comment. My first question is on the dynamics of the model that you presented at first, because I'm from the Institute of Economics at Scuola Superiore Sant'Anna, and we have a model that generates dynamics that are similar to yours, but due to the role of fiscal policy. Meaning, when you are in a recession or you are hit by a shock, partially, okay, you can use your inventories to replace production. On the other side, you have a loss in infrastructure, and this is relatively impossible to be recovered by inventories, and so you need demand for these large investments, and firms, they are losing money, and they are not willing to invest. So you can have similar results just if you account for a strong counter-cyclical fiscal policy. So I was wondering whether this can be also the case in your model or you have different channels.
Well, first of all, I should say that, you know, there's a lot of other work that looks at endogenous business cycles. There's a book, for instance, by Chiarella, Flushel, and Franke that there are various other things like this. I just don't know that any of these other people did some of the things that we did here. So there is a recovery of interest in endogenous behavior, okay? Now, clearly, that's part of the jokes that I was cracking at the beginning about various Keynesians. Clearly, you know, Keynes said government should do something, okay, not just sit on its hands. So you can change fiscal. In our model, there's no money, okay. But now I am interacting with some people. They asked me to also again okay, I forgot to put a slide on this trimester that we're going to have at the Institut Henri Poincaré in Paris in the fall about the mathematics of climate and the environment. So in that context, I got in contact with some, basically I wanted some of these people whose names I just mentioned to intervene, and they weren't available. And so they pointed me to some other people, and so they asked me to join a British proposal on doing, you know, including finance. There are people who are interested in the financial part within the whole climate economics complex. So we're not going to use exactly Nedim, we're going to use something else that they, you know, had already, but in the spirit that I was discussing here. So yes, there are lots of choices, and you know, you can get, there's no unique answer to optimal control of the economy, you know. But one can explore it. One can get some insights by using relatively simple models, including relatively simple ABMs. You know. One of the students actually, again, if I can have the presentation back. Okay. I mentioned in the, okay, sorry. So Célian Collomb, who's also a very brilliant former PhD, and this was also part of his PhD, but previously we did a paper essentially on comparing an aggregate predator-prey model, so a more sophisticated modern version of Lotka-Volterra on the one hand, and well, the ecologists don't call it agent-based, they call it something else. I forget exactly, but that's what it is. So we tried to compare, and for a matter of fact, people who do these agent-based models, including Axtell, whom I cited, you know, don't do bifurcations in these models because they don't know how to do them, and we were able to show a Hopf bifurcation by using SSA, okay, in the ABM. So I say you can, you know, you can, including relatively simple ABMs, not one in which, you know, every woman, man, and child in the US is, but, you know, somewhat more homogeneous model and so on. You can do such studies of how intervention can be helpful, should be conducted, etc.
Yeah. So you say you have a system of ODEs and also algebraic relations. So how sensitive are the solutions to changes in the coefficients? You've done a sensitivity analysis, I suppose.
Well, actually a little bit too sensitive. Okay, this is one of the reasons that we did try to do, you know, I mentioned the need for data assimilation, okay? And we started a project with one of the leading data assimilators in France, Marc Bocquet, but, you know, I mean, again, Stéphane was dragged away from doing science by his enthusiasm for doing good for humanity in other ways. So we never got to compare management-driven with, and you know, we didn't get to stabilize this NEDI model, and we didn't get to do lots of things. So I think there's quite a bit of, you know, open areas to cover, including in the project that you are planning to have here.
Okay, do we have any more questions for, do you want to have a question?
Michael, you mentioned the theorem of fluctuation or dissipation that you that concern this model. So, in this model means that there is the noise. Okay.
Well, there is no, you know. Okay, I'm sorry about interrupting. Okay, go ahead. Okay.
So, I think that in real world, in the economic evolution in time, there are some events that I can model with noise, in some sense. Is the noise this in your relation of fluctuation or dissipation that you mentioned but not stated explicitly? This is the first question. The second, when you have noise that is reasonable, which is the effect on the dynamics, for instance, of the model that you considered at the beginning, the model of Solov? What is the meaning of bifurcation when you have the noise in the system?
There is, you know, in the theory of random dynamical systems, of which you have here, I mean, unfortunately, Franco Flandoli couldn't be here because he's laid up in bed. But, you know, you have a good Stefano Galatolo and so on. You have a good school here. There is a counterpart of bifurcations. As a matter of fact, there are two kinds of bifurcations. They're called D bifurcations for dynamic and P for probability, P bifurcation for just when the PDF does something, you know, it bifurcates literally. So there are counterparts of that. But I should say that actually it's very interesting that this model is low dimensional and totally deterministic, okay? So the fact that I can understand very well why in the actual economic system I would have fluctuation dissipation relations, because there are lots of degrees of freedom and there is a lot of noise. You know, whether I drive my car today or I do not, actually I do not, but you know, most of the time, but all those things are not represented explicitly. So basically, you know, I once was invited to give a talk at the institute that Ecole founded in Kyoto. And so, you know, there's always this discussion in climate and other areas, what's deterministic, what's stochastic. You know, nature or humanity are neither deterministic nor stochastic. Deterministic is what you care about the details of, and stochastic is what you don't care about the details of, okay? So in the economic system, I can see very well why there would be the dissipation fluctuation relations, fluctuation dissipation relations. How come that this simple deterministic model did come up, I mean, you know, with something like that is again somewhat of a mystery. I mean, you know, you'd have to prove in the same sense that you do other things. It's a singular limit, etc., and it still, you know, keeps some of the properties of the full system, etc. But it's a non-trivial question.
Do you have a question? No. Okay. Very good. I think we should thank Michael. Michael is visiting Stefano for the next couple of days, correct? Till Wednesday. So I don't know, do you want to announce anything or no? Okay. Well, Michael, thank you very much for visiting Scuola Normale, Centro Ennio de Giorgi, and for giving this very interesting talk. And well, let's hope we keep interacting.